Hello everyone, welcome to a new video on electric vehicle technology. In today's video, we are going to discuss about charging infrastructure and standard. Particularly, we are going to discuss about charging standards. Before moving on to learn about charging standards, let's have a short recap of what we have discussed so far. We have discussed about electric vehicles and its types and why we need EVs. So as we know, EVs are vehicles powered by electricity instead of traditional fossil fuels, and we have battery electric vehicles, plug-in hybrid electric vehicles and hybrid electric vehicles as its types. The main reason for adoption of EV is that it's zero tailpipe emissions, and also in order to reduce the dependency on fossil fuels, people choose electric vehicles over the conventional vehicles. Now, let's get into the topic. Why EV charging standard matters? As we know, EV adoption is increasing worldwide and different manufacturers use different type of charging systems. So, these EV charging standards ensures safety and interoperability of the grid and faster deployment and user convenience. For example, what happens if every smartphone uses a different charger? If the smartphone uses a different chargers, then it makes the users inconvenient, and also the deployment of the smartphone will become less. So, the standardization reduces infrastructure cost, and also it enables global EV mobility also. Basically, we have three different charging levels. One is level 1 AC, level 2 AC and DC fast charging. And the power ranges starts from 1 kilowatt to 3 kilowatt for level 1 AC and 7 to 22 kilowatt for level 2. And DC fast charging range power range is between 50 to 350 kilowatts. And these level 1 chargers are used in home charging applications. For public and at charging stations, level 2 chargers are available, and in highways, DC fast chargings are available. Now let's empathize why we needed charging standards. Why do different countries adopt different charging standards? Because they adopt different charging standards because of its historical development and local grid infrastructure and regulatory decisions and protections. As electricity spreads, countries develop their own plug shapes, safety standards and power voltages, often prioritizing homegrown technology. So they develop each country, each manufacturer develop their own plug shapes with safety standards and for the power voltages adopted across their own country. So this is the basic EV charging architecture, where we have the EV, any form of EV, where the EV is being connected to, when it comes to the charging station, it is connected through ISO 15118, and then the charging EV charging stations will be then connected to the CPOs. So the main components of an EV charging architecture is we have an EV battery, onboard chargers OBC, and electric vehicle supply equipment, charging connector and grid interface. How these works is that when the EV is connected to the charger, the authentication begins and the power negotiation occurs, which means how much power is being used for the EV to supply. And then after this negotiation, the charging starts, and this is being constantly monitored through communication protocols to maintain safety. Basically, there are 4 charging standards: CCS, CHAdeMO, GBT and NACS. CCS is the combined charging systems where it supports AC and DC. And CHAdeMO is a charging standards developed by Japan, and it supports bidirectional chargings, which is highly used in V2G technologies. And GB is also a Chinese technology where it is large scale deployment in China. And Tesla particularly uses NACS standards with its compact connector and offers high efficiency. The current EV market growth is that the sales is globally exceeding and welcoming nature, because out of 10 vehicles that is being sold per day, 2 will be from EV. So major automakers transitioning to electric fields because of this transition in this EV market growth. And also the government is providing a lot of incentives and subsidies for EV buyers and charging infrastructure installation companies also. And the future projections is that the EV is expected to dominate the automotive market by 20 to 30. Currently, the EV market has seen a boom, and this growth is going to sustain in the near future. Now let's look about EV charging stations. What is an EV charging station? It is a facility or an infrastructure that supplies electric charge to recharge electric vehicle batteries. The main components available in a charging station are power grid, charging connector, that is the plug, and the control unit for safety and power management, and the communication interface. So these are the chargings that we have already discussed. And the basic charging standards are AC charging standards and DC charging standards that we have discussed so far. Here we have given the short recap of all those things. And this is how the coupler inlet for the plugs will be look like. So it varies based on the manufacturer types and the type of charging methods you use. So the major charging station networks are Tesla Supercharger Network, ChargePoint, Electrify America, EVgo, and Ionity in Europe. So these charging networks are commonly available in the European countries. And the main features of these charging network is that they provide real-time status update about their charging infrastructure, and also they offer mobile application integration for payment and navigation, and also they offer subscription based or pay-per-use models also. But though the charging infrastructure has a lot of advantages, they still face a lot of challenges. The first one is the infrastructure gap, because you could see a lot of EV charging stations in the urban areas, but very quite less in rural areas. And also the compatibility issues is still a common issue in most of the charging stations. And as long as the EV sales increases, the demand for power also increases. So this increased on power load on power grids increases and creates a stress for the power grid. And also this high initial investment for charging station deployment is a challenge for EV charging infrastructure. So these are the future trends in EV charging. First one is the ultra fast charging. Currently we have DC fast chargers. Now in near future we can expect ultra fast charging stations also. And currently the research is going on for wireless chargings, both in static, we have static wireless chargings, and also now they are looking for dynamic chargings for EVs. And the most welcoming V2G technology, which offers bidirectional charging for EV to supply energy back to the grid, and also renewable energy integrations for sustainable energy supply is also a future trend in EV charging. So these are the case studies that we can deeply look for when we learn about electric vehicle charging infrastructure. The first one is Tesla Supercharger Networks, which has 45,000 chargers globally. And Electrify America offers a largest open DC fast charging network in US. And then Ionity is a joint venture by major automakers, which also offers high-speed charging along highways. So, to conclude, the EV charging infrastructure is crucial for widespread adoption of electric vehicles because, as I already told, one among the 10 vehicles that on road is a EV. So, as long as the customer increases their EV usage, the need for charging infrastructure is also essential. So, hence, standardization, network expansion, and technological innovations is demanded to shape the future for EV charging. And also, the governments, industries, along with the individuals, need to collaborate in order to accelerate this transition from the combustion vehicles to electric mobility. So far we have discussed about what is EV, how EV charging matters, how EV charging standard is required, what are the EV charging architecture and its components, and how different charging stations are available, their charging levels, and finally its future trends. So thank you. Thanks for listening.